Hey, Janaya, how are you? Good to see you. Right on time, you guys. Hey, George. All right, guys, I want to see how you're doing on your vocabulary. Let's get started on this. If we could get going on this, I will not show you. I won't project it, so it won't, so people see your scores and so forth. But this will tell me if you need more practice or not. If you are taking necessary steps, is there 10 questions on motion? Remember distance, displacement, those kinds of things. We're going to have a post test on that. And I want you guys to get an 80% or better. So if you can get all of them correct, then I don't. Then I'll just mark you off the list that you don't need to study anymore. But if you um, need to study more, I just need to know that. Okay. Thanks, Janaya, for getting in there. How about you, George, Emma? How are you, Emma? Emma, Jay? Can you guys get in there, Reese? Reese, it's okay if you don't know what because I know you were having trouble getting in, but this gives me a baseline as far as what you know and what you don't know. Thanks, Reese. I really appreciate it. Doesn't count against you, but it does count for bonus or um, as far as people getting some extra points, which I'm going to try to do. Thanks, Emma. Thanks for the hi. How about you, George? Can you get in there? Thanks, Jay. It's early morning and it's 9:06. We got 7 people. Wow, people are not getting up this morning. So, all right. Hey, Ava, if you could get into that vocabulary quizzes for me, just to see how you guys are doing on your, um, if you need more practice or not. Just checking. If you do well on it, again, I'll put you in a drawing for some free prizes. Free prizes mean assignment prizes. So, hey, Anella, how are you? Good to see you. And so, who else did I not say hello to? Hey, Bugs, good to see you. If you can get in there, Caleb, if you could get in there, Madison, if you can get into that quizzes. I'm going to start this in 1 minute, 9:08. All right. Thanks, Anella. Guys really work hard. I know I push you hard, and we're trying to work you hard here. Again, keep you focused. Hey, Selah, if you could get into that quizzes, that would be great. George, if you could get into that. Hey, George, you said hello to me yesterday. How about you saying hello by getting it? Hey, thank you, George. Thanks so much. I appreciate it. Good job, guys. All right, Bugs, are you going to get in there? I'm going to start this in 1 minute. Selah, Madison, Caleb. Oh, okay. Gotcha. Emoji is the name. All right. Thanks, Janaya. All right. So let us get started on this. Thanks, Emma. All right. Pause this so that the my volume control. There we go. Good job, guys. Let's go back to, I shouldn't have shown that. Okay, let's go back here. All right, so we're going to be talking about, we're going on from distance and displacement to vectors, where we're going to use vectors and scalars. All right, so today we're going to talk about vector addition, calculating the resulting multiple of vector quantities. Okay, so this one, you could use a number line. And we're going to be so the question is why we're learning this. Suppose you walk 6 miles into the city and then walk 6 miles back. Would it be correct to say you traveled at 12 miles since that's how far you walked? Or would it be incorrect since you ended up at the same place you started? Imagine or examine the content in this lesson for the correct ways to describe motion. So motion we're talking about is about distance and displacement. And that's a pretty hard concept to get the, we're so used to distance, we're not used to displacement, and now we're adding that part in there. Okay, so we're going to watch this video, right? And
question, would you build a website for a major brand with more than 200 million users using Wix?
Get bad. Please do this. I'm going to share this link.
In today's video, we're going to look at the difference between scalar and vector query.
Okay, so I'm going to put this in the share external video. I think it'll be better because some people say that the volume is kind of low sometimes. All right, let me get my camera screen off here. Cancel. All right, so let's get back to what we were talking about, scalars and vectors. All right, scalars and vector quantities. So, so remember what we talked a little bit about yesterday. Let's see, we have some new people. Hi, Isaiah. We got some new people coming in the next hour. I don't think any new people this hour. And let's see who else didn't I talk to. Sincere, how are you? Namara, I'm glad you made it. Good to see you guys. Lissa, excellent. So a scalar is only magnitude. So examples are speed, weight, age, temperature, distance, miles per hour. Okay, they don't have a direction to them. All right, and vectors have both magnitude and direction represented by arrows and by their length. Okay, you can also use them. You can also do if we're doing a scalar, or let's say we're doing a vector, sometimes we can just put a plus for right, a minus for left. We can also use a plus for up. So if we use a number, we can use these minus and pluses for up and down, left and right. Okay, so there's a lot of different ones in here. So up and down, makes sense. Down is negative. We don't want to be falling into the earth, hitting our head, breaking our bones. Plus and minus, plus is right and minus is negative. Probably, again, left-handed, maybe they thought people with left hand was a negative idea. Okay. So examples of velocity. So if you take speed and give it a direction, then it is a velocity. Force is a magnitude because we're pushing to the right or pushing to the left. Acceleration, speeding up or slowing down. Momentum and displacement we talked about is that shortest distance between the start and the stop points here. All right, so category these into either scalar or vector. If you could do that with, I think I have, yep, I got some responses here. So let me put a poll here for those people that are not doing this. Okay, so let's do this. 5 meters. Is it a scalar, or a B vector? Thanks for participating on this, ladies and gentlemen. I appreciate this. A or B? Let me give you the poll here. A or B, scalar or vector? All right. So 5 meters. All right. Good job. Abriana, Jay, Selah, good job. You guys are doing great. Thanks so much for getting there. Emma. All right. Okay. So if I said 5 meters east, it would be a vector. So if I said east here, if I said east on this, or if I said plus 5 meters or minus 5 meters, then it would be a vector. But it is a scalar. Okay, it's a scalar. All right, so we got 8 people out of 20. Thanks so much for those guys doing that. All right, so let me ask you this, start another poll. How about 256 bytes? 256 bytes, B-Y-T-E-S. We haven't seen those in a long time. So let's ask that question. A or B? Is that a scalar or vector? All right, you don't see north or south or east or west, right? All right, so you're going to be saying it's a scalar, right? So this is a scalar as well, right? Because there is no direction to it, right? So no direction, right? Let's go with one that shows a direction, right? Let me do this one. Start a poll, and let's do 5 miles north. 5 miles north. Miles, oops, okay, I forgot to get that. Okay, 5 miles north. Get this out of the way. Okay. Enter. All right, so I guess we'll go 5 miles north. It won't let me put it in there. North. So A or B, what is 5 miles north? Scalar or vector? Oh, we got some coughing going on here. All right, so good job. It is a vector because we have a direction, right? Thanks, George. Thanks, Abriana, Anella. All right, we got us a vector here. All right, so let's take a look at those people that show the responses. Scalar, vector, vector, scalar, scalar, scalar. Good job. Somebody has those. Okay, yep. Vector, you know, if you can see the direction, then you've got it. Excellent. All right, so this one is a scalar. If you're covering it over, this is, I see that. Yep. Yep. Excuse me. So I've got 1, 2, 3, 4 people. Let me thank those people that are participating in this. All right. Thanks, Brianna and Serenity, Cece, Anella, Reese. Thank you much. Kalani, you were in there. Janaya, you were in there. Sayla and George, if you guys could get in there and get these done, that'd be great. I appreciate you all. All right, so let's move on to the next one here. I'm going to hide these. So classifying them, here is the notes: mass, length, distance, speed, power, energy, displacement, velocity, acceleration are your vectors. So today what we're going to do is we're going to try and explain how to use these vectors, okay? So of these, which has the greatest magnitude? All right, so I'm going to say red is A is red, and B is blue. That makes sense. B-L-U-E, blue. Okay, so let's do this one. Red or blue, which has the greatest magnitude? So if we were to put a number on this, which one, the red arrow having more magnitude or the blue arrow having more magnitude? Okay, so we got two people, Janaya, Serenity, Abriana, and Reese. All right, thanks so much. Okay, we've got, for those people that are responding, okay, I got 2 out of 8 on there, so just circle or put a check mark on this. Let's see what they did. All right, one person put red, one person put blue. All right, so from the video, it said that we can, the longer the arrow, the more, the bigger the number that we'd associate it to, or bigger the magnitude. So this one's correct. The blue arrow is the one that has the most magnitude, okay? And if we were to do this, if we were to put some numbers on these, we could say this is 5 and this is 10, right? And we're going to the right, so we're going to put a plus 5 and plus 10, all right? Because we're going to the right. If it was going to the left, it would be negative. So publish the poll. Most of you guys said blue. 5 out of 9 said blue. So let us take a look at what we do with these. So to add vectors, okay, so think about this as like a force. We'll be talking about force in the future. We're pushing, okay? So let's think of the blue arrow as the person that has the ability to push harder than the person with the red arrow. So if you're thinking about your brother or sister, you're small, you know, you are bigger than you, maybe your sibling is younger. They could be helping you push something, but they can't push as well, okay? So when we add these vectors, we add them what they call tip to tail. The sum of the vector drawn in the tip to tail is the how much the vector adds up to. So the sum is from the green to the blue arrow in the back to the red arrow in the front. Okay, so if you think about that, if makes sense, if you are pushing something, if you get some help, you're going to push it a little faster, a little harder. Okay, so we add those tip to tail. Right, so adding two vectors, remember, we add these 3 and we have to put a plus in front of them. So if I were to add those together, let's start a poll. Okay, what would the total vector with add a plus? So it's going to be they're going to the right, so add a plus to this. What number would you make this total? What would be the total if you added those together, tip to tail? All right, remember to add a plus to it. There you go. I got a +8. Good job, Brianna. Because we're going right. If we use just an 8, that's a scalar. If we use a +8, we're saying it's a vector. Okay, so if you're putting a +8 by it, it's a vector, right? Thanks, Serenity. Thanks, Madison. Thanks, Anella. Right, so we are adding those together. Yeah, so +8, +8. So we want to make sure we put plus for the right direction, right? There you go. +8, +8. Thanks so much, guys. Right, so you got +8 here. Now, on a number line, if you remember your integers, and some of you may have, I know that I've taught 8th grade math before, and people still struggle with integers, so you have to use a number line. Think about a number line here. All right, so you can put the numbers magnitude 2 and add this and subtract. Think about a number line. So you can put them, tip to tail again, right? Get your 8 there. Probably, like I said, should be a +8 because we're going to the right, but it's because we're showing the arrows, you know it's going to the right. But when we ask for an answer, you got to be real careful of that. Nothing. What happened? Okay. So let's determine the magnitude and direction. Right now, we're going to take these and we're going to put them together like this. Oops. Okay. So we take this 3 and put it on top of the 5. Okay, the longer one. And you'll notice that what's left is a little bit of blue, which has a magnitude of 2 and it's to the right. So this is a +2. +2 right in here, okay? So when you have them going in the opposite directions, then you have to subtract them, okay? All right, let's try this one here. Okay, so let's add these together, right? You're going to put this one on top here, right? You're going to put that there for 9. And then you're going to put this other one. Let me try a different color here. Let me use yellow. And you're going to come back 3. Okay, so what kind of answer would you get this one? Start a poll. All right, so is it going to be a plus or a minus or minus? Let's ask that first question. Is it going to be a plus? Directions, is it going to the right or is it going to the left? Let me go plus or minus, which is right or left. Right or left? Type your answer in here. Right or left, plus or minus. What do you think? Right or left? When you finally get it done, what do you think is going to happen? Right or left? So I'm pushing with 15 to the right. Another person's pushing 9 to the left. And then there's a smaller person pushing against us with a force of 3. All right. So, okay. So most of you guys are saying, I got one person says left. All right. Most people are saying right. Right. So if we add these vectors together, let's turn this off here, see what people got. Show answers. +21. Good job. +21. You guys are right. It's plus, right? +21. Yep, you got 9 plus 15 is 24. And then take away 3. right? Plus 21. Excellent, excellent. So we put them on top of each other, right? And that's how we get those. Okay, so vector addition can be complicated, all right? So you put tip to tail, and again, depending on the angles, and we need the Pythagorean theorem to help us with that. But we're not going to be involved in the Pythagorean theorem to solve these triangles, okay? Sines and cosine. So if a car travels 4 kilometers north and 2 kilometers west, so let me draw this for you, right? So 4 kilometers north, right? So I'm going to use an arrow here, right? And that's a 4. And 2 kilometers west, okay, my resulting direction is going to be that way, okay? So that's why I said you need the Pythagorean theorem, but we're not doing that here, okay? Just to let you know that there is other way, you know, that there is more to this than we're going to just do straightforward plus and minuses, right? That's the total distance. Oh, I didn't do it right. I didn't get my arrows in there correct. So let's try this one. If you have a displacement, travel 50 kilometers west. So let me say that's 50 kilometers west. And then I'm going to take a different color here. I'm going to put this in blue. I'm going to take, and I'm going to go 50 kilometers to the east. What's my displacement? What's my displacement? So give me a number, put a plus or minus in it. Right? What's my displacement? Type a number in there. Right? What is that? I go 50 kilometers to the west and 50 kilometers to the right. Remember, we started here and we ended here. All right. Good job, Jay, Abriana. Right? So you're right if you said distance is 100, but we're saying displacement. Remember, displacement is how far away from the start and finish line. Okay, so start and finish line. Right, so we've got a lot of people saying 0 here, which is true. 0 is the correct answer because displacement, if it was distance, we'd say 100, right? But because we started here and came back to that same spot, we're going to have 0. Same thing, and like if you're going around in a circle on a oval track or a circular track, if you start and finish here, right, your displacement's going to be 0. Your distance can be 100 or 1,000 or whatever meters it is for that circle. But remember, your displacement's always going to be 0 here. Okay. Let me see how this one works here. All right, so start and finish, displacement is going to be 0. Okay, so we are about done with this. We're going to stop right there. So what I'd like you guys to do, all right, so this is your exit quiz. Let me stop this for a second. I've got an exit quiz for you that's 6 questions about adding and subtracting vectors. So let me give you this real quick. Exit. All right. All right, so I'm going to have you guys do this in team mode, continue, so that we can kind of hide the, so everybody's going to join the team here. All right, so let me do this. All right, start. All right, copy link. All right, so you guys are going to be part of a team. So let's do this real quick. I'm going to turn the recording off here. Ladies and gentlemen, I'm going to pull people out in the So I'm going to be pulling people out in the breakout room to go over vocabulary for the vocabulary. So I'm going to take a look at the quizzes and see how you guys are doing. I'm going to pull you guys out for the last 15 minutes. So again, if you feel you did really well on the vectors, I would try the week 1 assignment 2, which talks about vectors. All right, so there's some vector questions, and the quiz is on Friday, but you certainly can get a start on that as well. If you have anything from last week, a lot of people missed W0 quiz 1, okay, on at class expectations. That became a 0 the other day and brought a lot of people's grades down. So check your grades and make sure that you're catching up on things. Again, there is also the bonus from yesterday. If you didn't do the bonus in class, you can still do the bonus on the Nearpod as well. Check the module for conference videos as well, and also the notes for anything on scalar and vector that you can do during this time to catch yourself up if you haven't been here in a while. All right. So I'm going to pause the recording